What if I told you there's a model you can run entirely on your own machine? No subscription, no API key, no data leaving your computer. That is genuinely competing with GPT-4o on coding and reasoning benchmarks. Because that's exactly what Qwen3.5 27B is doing right now, and a lot of people are sleeping on it. Hey, I'm Maya. Welcome back to the Operator AI. If you're into running powerful models locally, or you're just trying to figure out whether the open source AI scene has finally caught up to the big paid players, this video is for you. Today, we're doing a full review of Qwen3.5 27B, Alibaba's latest open weights release. We're talking benchmarks, real-world performance, the hybrid thinking feature, and whether you can actually run this thing without a server rack in your basement. Let's get into it. So first, what exactly is Qwen3.5 27B? It's the 27 billion parameter version of Alibaba's Qwen3.5 series, and it sits right in the sweet spot of the lineup. Not so massive that you need enterprise hardware, but not so small that you're making sacrifices on quality. The model was released as open weights, meaning you can download it, modify it, and deploy it however you want. It supports a context window of up to 128,000 tokens. That is genuinely enormous. For context, that's roughly the length of a full novel you can feed into a single conversation. It's built on a dense transformer architecture, not a mixture of experts like some competitors, which actually matters for local deployment because the full model is active on every inference. No routing, no partial activation. What you see is what you get, consistently. It's trained on a multilingual corpus, with strong coverage of Chinese, English, and a range of other languages. And Alibaba has emphasized reasoning, instruction following, and code generation as the core capability pillars. Those claims hold up more than you'd expect. Now let's talk benchmarks, because this is where it gets interesting. On MMLU, that's the massive multitask language understanding benchmark, basically a broad knowledge test, Qwen3.5 27B scores in the low 80s, percentage-wise. That puts it in the same general tier as earlier versions of GPT-4 and solidly ahead of most models in its parameter class. On Human Evil, which tests Python code generation, it's hitting numbers in the mid to high 80s. For a model you can run on a gaming PC with 48 GB of VRAM, that's remarkable. Claude Sonnet, for comparison, sits in a similar range, and that's a cloud model you're paying per token for. Math reasoning is where things get more nuanced. On Math and GSM 8K, which are competition-style math problems, Qwen3.5 27B performs well on the standard inference mode. But the gap widens significantly when you enable thinking mode. More on that in a minute. One thing worth noting, benchmarks are a starting point, not the whole story. I ran my own tests, and I'll tell you the results were mostly consistent with the numbers. Mostly. The model can occasionally over-explain simple tasks, and it has a slight tendency to be verbose when you haven't specifically told it to be concise. Keep that in mind for prompt engineering. Let's talk about what this model actually feels like to use in a real workflow. I threw 3 categories at it: coding, long-form reasoning, and document summarization. On the coding side, honestly impressive. I gave it a multi-function Python script that involved async API calls, error handling, and JSON parsing. First pass was clean, well commented, and ran without modification. I then asked it to refactor the same code for performance, and it didn't just shuffle things around. It actually caught an inefficiency in how I was opening file handles. That's not a trivial catch. For reasoning, I gave it a multi-step logic puzzle, the kind where you have to track 5 or 6 variables and work backwards from a conclusion. It got it right, and more importantly, it showed its work in a way that was easy to follow. Contrast that with smaller models, which often arrive at the right answer through what I can only describe as confident guessing. Document summarization over long contexts was solid but not perfect. It handled a 40-page technical PDF well, but I noticed some compression artifacts in the summary, meaning it collapsed related points that should have stayed separate. Not a deal-breaker, but something to be aware of if precision matters for your use case. Okay, the hybrid thinking mode. This is one of the headline features of the Qwen3.5 series, and it deserves its own section because it changes how you should be using this model. Thinking mode is essentially a built-in chain of thought system. When you enable it, the model internally reasons through a problem before generating its final response. You're not seeing every step in real time, unless you're using a front end that surfaces the thinking tokens, but the model is doing more work before it talks to you. The practical effect? On hard reasoning tasks and complex math, the quality jump is noticeable. We're talking 10 to 15 percentage point improvements on benchmark tasks when thinking mode is active. On simpler tasks, You're just adding latency with no real benefit. So the smart play here is to build a workflow where you're toggling thinking mode deliberately. Use it for multi-step problems, architecture decisions, debugging gnarly code. Skip it for summarization, quick lookups, and anything where speed matters more than depth. Most frontends that support Qwen 3.5, including Llama with the right model tag, and LM Studio, let you toggle this at the system prompt level. It's not buried. But if you've been running the model without ever turning it on, you're literally leaving performance on the table. Let's get real about the hardware question, because this is the make or break for most people. The full 27 billion parameter model in 16-bit precision needs roughly 54 gigabytes of VRAM. That's out of reach for most consumer setups right now. But here's the good news. Quantized versions change everything. A Q4-K-M quantization, that's a 4-bit format with medium quality preservation, brings the VRAM requirement down to around 18 to 20 gigabytes. A single RTX 490 or a pair of older 3090 cards gets you there. And if you're on Apple Silicon, an M-series Mac with 32 gigabytes of unified memory handles this comfortably through MLX or Llama. The speed at Q4 is genuinely usable. On an M2 Max with 36 gigabytes, I was seeing around 30 to 40 tokens per second. That's fast enough for real work, not just experimentation. My honest recommendation, if you have the hardware to run 27B locally, this is currently one of the 2 or 3 best open weights models you can use. If you're below 18 gigabytes of VRAM, look at the 14B or 8B versions in the same family before you compromise too much on capability. Alright, here's the bottom line on Qwen 3.5 27B. Benchmark performance is genuinely competitive with paid frontier models in its tier. Real-world coding and reasoning hold up. The hybrid thinking mode is a legitimate differentiator, but only if you use it intentionally. Hardware requirements are manageable with quantization, especially on Apple Silicon or a modern consumer GPU. The action step right now, pull it down through Llama using the Qwen 3.5 27B tag, run the Q4-K_M quant if you're memory constrained, and test it on the actual tasks that matter in your workflow. Don't benchmark it on random trivia, benchmark it on your work. If this review saved you some time and helped you figure out whether this model is worth your attention, drop a comment below. Tell me what you're actually using local models for right now. I read every single one. And if you're not subscribed yet, what are you doing? We cover this stuff every week. Hit that button. I'll see you in the next one.